Greetings, geometers. On this lovely day, what we want to attack is we want to prove that right triangles are congruent using a super secret theorem called hypotenuse leg. So first, let's do some introduction about right triangles, and then we'll go into proving things. So let's start off here. One of the tent flaps over here was damaged in a storm. Can you use the other flap as a pattern to replace it? So the question is, can we just make a pattern out of this and then replace it on the other side? So in other words, are the two triangles congruent? And we say, well, sounds like it should work, right? But let's see what the given information is. Well, we know that this side is congruent to itself by reflexive property. We're told that this is congruent, and of course we know that both of these are right angles. So what do? Well, so far we have a pair of angles, a pair of sides, and a pair of sides, or side-side angle. And so we say, we don't have a theorem that covers this yet. So at this point we say, my instinct says yes, because these two should match. But right now, I don't have that information. So let's do some introduction with some right triangles here. First off, we know it's a right triangle because one of the angles, one angle is right. Okay, so legs are the non-hypotenuses. So these two here are the legs, not because it's on the bottom and on the left, but because it's the right angle is included. And the hypotenuse is always opposite the right angle. By the way, hypotenuse comes from Greek and Latin. That just means to pull tightly. Pull tight. Why? Well, because if you have a string that's dangling and you pull it tightly, notice that it could form a right triangle there if it were a wall and the ground. So we do have a theorem. Our instinct says that these two up here should be congruent. Well, it turns out it is true. If the hypotenuse and a leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the two triangles are congruent. So all we need for the diagram is just the hypotenuse and one of the legs, for example, these vertical legs here, of a right triangle. So it has to be 90 degrees there. So therefore, we know the two triangles are congruent. Now, what would the proof for that be? Oh, the proof is a little bit crazy. The proof requires me to start off with two triangles, like so. And we are told that one of the legs are congruent, and the hypotenuse is congruent, and of course, we have right angle here and here. So how do we approach this? Well, what we need to do is I'm going to extend this out here, and I'm going to put a point somewhere on this line such that AC is going to be congruent here. When we do that and connect the dots, it turns out that this triangle here is going to be congruent to this triangle here. Why is that? Side, angle, side. So now I know that this side here is congruent to AB up there. So by the transitive property, these two sides have to be congruent. And if those two sides are congruent, then that is as well. By the base angle theorem, also known as the isosceles triangle theorem. So these two triangles have to be congruent. Why? Angle, angle, side. Angle, angle, side. And since these are congruent and these are congruent, then that means the transitive property that these two are congruent. So there you go. Little bit of work there, but we were able to do it. That's not a formal proof. Obviously, I just walked you through it. So we're going to decide if there's enough information to prove that the triangles are congruent. Explain your answer. So notice here, by the reflexive property, RT is congruent to itself. So in this case, I have a pair of H's, my hypotenuses, leg, and it's a right triangle. So the answer is yes by hypotenuse leg. Well, how about this one over here? If I were to split up the two triangles, I have this triangle here, and then the other triangle overlaps over there. So let me just draw that here, something like that. Well, clearly BC is congruent to itself, so that's congruent. These are both right angles, and I have this angle here and this angle here. So if I follow a pattern, angle, angle, side, angle, angle, side. So yes, the answer is there is enough to prove that these two triangles overlapping are congruent. Now, you might have said, well, what about this triangle here and this triangle here? Well, there might not be enough information for those two, but for the overlapping triangles, there is. What about number 6 here? Number 6 here, we have parallel lines here and here cut by this transversal. So what do I know? This angle is congruent to this angle. What else do I know? I have parallel lines cut by another transversal, so those two are congruent as well. However, we know nothing about side lengths at all. I don't know if R is the midpoint of QT, so I can't say those are congruent necessarily. These are parallel, but not necessarily congruent. So all we have is a pair of angles and a pair of angles. So my answer is not enough information. Now on page 2, we want to see what additional information would prove each pair of triangles congruent by the hypotenuse leg theorem. So notice here, I have what looks like the hypotenuse right here, and here I have, these are legs, so the only thing we're missing is this right here, that I have right triangles. So angle A and angle Q are right. Notice I'm not saying they're congruent, because if they were congruent, that would be angle side side, and there isn't a theorem for any generic angle. It's got to be right angles. So how about this one here? What are we missing? Well, we have a pair of sides, we have a pair of hypotenuses, so I just need to know if these two angles are right. Again, they have to be right angles. Next, down here, we finally do have a pair of right angles. Great. So we have a pair of legs. We just need to know if the pair of hypotenuses are congruent. So segment LN, or side LN, has to be congruent to side XZ. And lastly, over here, by reflexive property, that's congruent. We have right angles. So again, I need my hypotenuses, TR and TV, need to be congruent for HL to work there. The last thing we want to cover is to complete this proof, or these two proofs. And this first one's going to be a paragraph proof. So we are told that RT and SU are perpendicular. We're also told that RS and RU are congruent. So first thing, it is given that RT is perpendicular to SU. So therefore, we know that angle RTS and angle RTU are right angles. Why? Because perpendicular lines form right angles. We also know that RT is congruent to itself by the reflexive property, and we are told that RU is congruent to RS. So the two have to be congruent by HL. Here's my hypotenuse, and the leg is there, and we established that they were right triangles. This next part is that we want to write a flow proof, and you're going to use the information from the diagram to prove these two triangles are congruent. So just by way of a plan, I can mark that the reflexive property says that BD is congruent to itself. So I do know that this triangle here is congruent to this triangle here by HL. Where's my hypotenuse? This one congruent to itself. These legs here congruent. And we have right triangles. So I do have to establish right triangles, and I have to show all the congruences. So H, L, and right triangles. So let's start off by proving that they are right. So angle A and angle C are right angles. And what's the reason for that? That's given information. Now in a separate line of thought, I'm going to show a pair of sides congruent, in this case the legs. So AB is congruent to CD, and what's the reason for that? That's given information. And lastly, BD is congruent to itself, and that's not given but reflexive property of congruence. All right, so now what we've established is because that's true, and that's true, we know the two triangles, ABD and triangle CDB, are congruent, and the reason for it is HL. So it's actually not overly crazy, but what makes this a flow proof, again, is that each of these essentially columns are lines of thought. I'm doing everything I can to prove the triangles are congruent. On a separate note, I need to show HL and H and L, and then bring them all together. Since I have a right triangle, hypotenuse and leg, those two are going to be, triangles are congruent. Now I'm signing off. Good luck and Godspeed to you.